Hi all and welcome back to the channel. Today we have a super exciting video for you guys. So in this video we're going to take a break from our Solidity Fundamentals series, which has been very prominent in the channel the last few days, and we're going to have a look at creating our very own supply chain smart contract in Solidity. So why do we do this? Well, this is going to really tie together some of our foundational concepts into one concise video. And supply chain management is really one of the key benefits or the key use cases that can actually transform the world as we know it. So this is going to be a relatively simple contract. Obviously we can add functionality later, but the basic premise of this is that an owner, so the person who deploys the contract, is going to have the capability to add items in the form of a struct to this contract, and then other users will have the option to buy this and have their own address assigned to this particular item that's put up for sale, and that is how we verify ownership. So without further ado, we're just going to jump into the code, and a lot of this will become clearer once we actually start coding. So as you can see here, we are in our Remix IDE. This is a really useful online resource and we have been using it for a while on this channel. So we're going to begin with actually defining an address variable. We're going to make this address payable. So the payable keyword just means that it can receive ether. And we're going to call this address the owner. Now in our constructor function, we're actually going to assign this owner variable. So what does this do is we're simply assigning it to the person who actually deployed the contract. So it's msg.sender. And the constructor function is simply a function that executes once when the smart contract is actually deployed. So if we save this, we're getting an error already. Yeah, and what we need to do is we actually need to wrap this with around the payable keyword as well, as we have defined our owner variable as payable. So we're just going to do that now. And I spelled payable wrong. Perfect. So now we actually have our owner variable defined. We're going to create a struct that will actually define what type of items we will be selling. So we're going to have a struct, we're going to call this struct item, and we're going to define our fields here. So the initial fields will be a uint, and we're going to have this as price. We're going to have a string, and we'll assign this to as our description. We're going to actually cut this down for easiness, and finally we're going to have an address, and we're going to have this as the buyer. Okay, that's initially our first struct defined, and this is how we define each item that we're going to put up for sale. So our next step is to actually create a mapping for all the different items that we're actually going to put up for sale, because obviously we're not just going to have only one item. Like with any supply chain, multiple items will be available. So we're going to have this mapping take a uint, and it's going to reference our item struct. It's going to be a public mapping, which means anyone can see it, and the mapping name is going to be called items. And we're also going to actually define a counter variable. We're going to make this private because there's no need to. And we're going to have this be called counter, and we're going to initialize it to 0. So this is going to serve as the key whenever we're actually adding an item into this mapping. Okay, brilliant. Now we have some very basic structure to our smart contract. The next is we're going to actually create a modifier. So a modifier is a great way of actually making sure that our functions actually conform to certain standards. So we're going to call this modifier only owner, and we're going to make sure that this contract, whenever this modifier is called, only the owner. So we're going to say msg.sender equals two equal signs and owner. And to actually finish our contract, we do underscore semicolon, which is a requirement whenever we're creating modifiers. So what this modifier does essentially is making sure that whenever it's attached to a function, that the only one can actually execute the function is the owner themselves. We're actually going to create an error message. So you are not the owner. So this will happen if this requirement is not met. The user will be given an error message, and this is the error message that they will receive. So we're going to save that and make sure that's okay. And we're also going to create a second modifier called paid enough, which we're going to actually attach to our buy function. So it's going to be a very similar format. We're going to create another requirement. So this time it's going to be msg dot value is greater or equal to the price. And we're actually going to have this modifier taking a value. So it's going to be a uint, and it's going to be price. So modifier can be created without input or with input. So without input, we typically leave off the brackets, as can be seen in our only owner example above. So if we save this now, we don't have any error messages, which is fantastic. So we're going to actually get down to our functions, which is the exciting part. So as you can see here, we have two functions, add and buy. So add function, essentially all it does is it's adding a value to our items mapping that we defined up here. So I'm going to build out this function a little bit more. So we're going to say only the owner can call this. So we're calling the only owner modifier to make sure that only the owner can actually execute this contract. So it's going to, this function is going to need some input. So what do we actually need here? So we need some input for our uint price. So uint underscore price. So we're going to say a string memory underscore DSC. And that's the only input we need at the moment. So to add an item to our items mapping, we're going to reference our items mapping, and then we're going to give it its key, which is going to be the counter variable, which we have defined up here. So if we reference our counter variable, and now we're going to initiate a new item. So item is lowercase. So our first value is our price. So it's going to be our underscore price. Our second value is our description. And the third value is going to be an address, but we're going to initialize this to 0. And after this line of code executes, a new item will be put into our items mapping. So after this, we're going to iterate our counter variable by 1. So if we save this, hopefully we have no compilation errors, and we don't. So that is perfect. And now we're actually going to move on to our buy function. So we're going to use our paid enough modifier. So this is going to take in the msg.value, which is the actual amount which is sent to the function by whoever calls this buy function. And we're going to have it only take one input that is the ID. Brilliant. So if the owner has actually paid enough, or if the caller of the function has actually paid enough, then this function will execute. So what do we need to do here? First of all, we need to transfer the owner of the contract, the actual value of msg.value. We use this using the .transfer method. So we're going to say msg.value. So what this does is essentially pays the owner the value of the item that this person is buying. And then finally, we're going to update the buyer on our struct. So we're going to say items underscore ID dot buyer equals msg dot sender. And what this essentially does is it's paying the owner the price of the good that they just added, and it's also transferring the ownership from the initial owner to the new buyer. So if we save all this, looks like we have a little bit of an error. We can have a quick look here. What we actually need to do is we need to make this function payable as well to allow it to actually receive and process Ethereum. So brilliant. I think that is pretty much done. So what we can do now is we can actually deploy this contract. So we're going to deploy the contract. And we can see our 3 items here. So as we're the owner, we're going to set a price of 100. We can give this item a description. So let's say desk. As you can see, this is being accepted. And we can have a look and make sure that our item has been accepted. So we can see our 0. And we can see that this has indeed been added to our items mapping. So that is brilliant. Now also what we're going to do is we're going to change our accounts here, and we're actually going to call our buy function with a different contract address. So we're going to actually pass its price, so 100, and we can see if we can actually buy this. And yes, we can. So if we actually update, this is now updated our item in our items mapping. So if we call this function again, we can see now that this buyer has indeed been updated. So it actually matches the account that we just used to call the buy function. So that is pretty much it for the video today, guys. We have gone through and created a very basic example of how we would actually implement our own supply chain smart contract. Now obviously in the futures there is ways to actually add additional functionality. We can actually create an enum for maybe perhaps storing the state, so it might be in available for sale, and then it might go into actual bought whenever the buy function is actually being successfully transacted. But that is an example of how we can actually extend the functionality of this function. But we've covered quite a lot today. We've covered quite a different, quite a lot of different variable types. So hopefully you found this video useful. And if you have, as always, please give a like to the video. And if you're feeling extra generous, a subscription would be fantastic as well. So that's pretty much it for today, guys, and we will catch you in the next one.